In section 3.1, we're going to look at quadratic models, which when we're talking about quadratic functions and models, at least to start out with quadratic functions, remember that means we're going to have something with an x squared term in it, which means we're going to be looking at good old parabolas, at least to begin with in this section. So we'll start out with some parabolas. Some parabolas point up and some parabolas point down. How do we know whether or not a parabola points up or down? Well, remember from previous math classes is that a parabola points up if the number that's out in front of the x squared term, remember when you have a parabola, you usually have an a out in front of your x squared term. That a is what's going to determine whether or not your parabola is pointing up or down. If the a is positive, your parabola will point up. So if your a is positive, it points up. If your a is negative, your parabola will point down. What we'd like to do is talk a little bit more about parabolas and go a tiny bit more in depth than what you may have seen before, but usually we do cover this in our college algebra courses, which is the most important part of your parabola is what's called a vertex, which is, if it's pointing up, is the base. If it's pointing down, it's the peak here. And so we've got this point that's either at the bottom or the top, depending on the parabola, and if it's pointing up or down, that's called your vertex. And that vertex is either considered to be a minimum or a maximum. It's considered to be a minimum if it's a low point, like it is on this one where you're pointed upward. It's called a maximum point if it's pointing downward, because then it's the highest value. And we also have something nice about parabolas is whatever happens on one side of the parabola happens on the other. You have this kind of mirror image. And it has a mirror image from cutting it down the center where the vertex is. And that's a vertical line. That vertical line actually has a special name. It's called the Axis of Symmetry. A lot of times you'll see me shorten Axis of Symmetry to AOS just because it's kind of a pain to write out a lot. And it's a vertical line, so it actually has an equation. The Axis of Symmetry will be a vertical line, which means it'll have an x in it, and it will equal just some number. So an Axis of Symmetry is x just equals some number. So the question becomes, how do we find the vertex of our parabola? Well, we've learned several ways. You can shift left, right, up, and down and kind of find the vertex, or there's actually a formula to find the vertex. The formula to find the vertex says, just to find the x value for the vertex, you'll use x equals negative b over 2a. So that your first thing that you would do is you can use the formula x equals negative b over 2a. It's kind of the first part of the quadratic formula. The top part always starts with the negative b. The bottom part always has a 2a, so it's part of the quadratic formula. And then what you would do with this is after you get that value, then you would plug it in to find the y that matches up with it. Then you would have a point. You'd have the x you found originally, comma, then you'd have your y, and then that would be your vertex, and you could plot it. And that would be the center of your parabola, either the peak or the bottom. Continuing along, so we now have a formula to find the vertex of a parabola. As long as it's in quadratic form, which is the ax squared plus bx plus c. That's what we're used to seeing. And we talked about this. When the a that's out in front is greater than 0, our parabola points upward. when it's positive. And when the a that's out in front of the x squared is negative, the parabola points downward. When the parabola points upward, we call that vertex point a minimum because it's a lowest point. When the parabola points downward, we call the vertex a maximum point because it's the highest value. And we also have something nice with parabolas where if you cut it down the center with a vertical line, notice you have the same picture on both sides. It's a line of symmetry, so we call it an axis of symmetry. And because it's a vertical line, we'd give it an x equals, and it ends up being a number. Well, it ends up being the same number you have for the vertex. So the x value for the axis of symmetry in the equation is x equals that negative b over 2a we were just talking about. So what that gives us is it will be that x equals some number will be the equation of the vertical line down through the vertex so that both sides of the parabola are the same. And we get tired of writing out axis of symmetry, so like I said before, we'll shorten that to AOS. So if you ever see AOS, that's what we're referring to. So now this gives us another option that we don't have to do completing the square or anything like that, but we can still graph a parabola. So let's take a look at a couple of examples. So let's take a look at this first one. In this first one, we have something that's perfect that's in quadratic form. And we can talk about our A, B, and C. Notice our A, you really can't see our A is hidden. It's the number that's out in front of the x squared. Well, if you can't see it, it's a hidden 1. So that means our A is 1, our B is -2, and our C is a positive 3. So if we wanted to find our vertex, which is the most important part of a parabola, we'd use our formula we were just talking about. It's x equals -b over 2a. Well, negative, and we'd have the b. Well, we just said b is -2. So be careful. The negative from the -2 would turn this negative into a positive 2. And then on the bottom, we have our 2 times a. Well, we just said that a is 1, so we'll replace the a with 1. So what that gives us is now a positive 2 on top over a 2 times 1, which is 2 on the bottom, which gives us a 2 divided by 2, which is 1. So let's take a look at what this means. So what this tells us is that we now have a value that we know our vertex is going to be down at the x-axis at an x value of 1. So we've got part of our vertex, but our vertex is a point. So at this point, we've only got the x value of the vertex. We still need to find the y. How do you find a y value once you already have an x value, though? You've got to plug it back into your equation. So I'm going to take my x that I just found, which is 1, and plug it in wherever there's an x into my parabola. So we're going to plug in p of, and we're plugging in 1 for x. So let's see what happens. Well, we would have, let's see, the first value would have is 1 squared minus 2 times 1 plus 3. So the first thing that we do is follow our order of operations, which is going to tell us that we want to do our exponents first. So we do our 1 squared first. Our 1 squared here is just 1. Then working left to right, we could also do our -2 times 1 here, which is -2. And we have our plus 3 at the end that we can leave the same. Keep going. Now let's add and subtract normally. We've got 1 minus 2, which is negative 1, plus 3, which is going to give us a positive 2. So what that does is that now gives us a y value now of positive 2 for our point. So our vertex is now at 1, 2. So now I can go plot that point, which is over at 1 and up at 2, and that's going to be part of my parabola where my vertex is. This also means if that's where my vertex is, that's also going to be my axis of symmetry, meaning where I'm going to cut down the middle and I'll have the same picture on both sides. So what that means is my axis of symmetry is also at that value at 1. However, it is a vertical line. It needs to be an equation, and it always is an equation involving x's because you're cutting through the x-axis, so it's x equals 1. So we'll make sure we put the x out in front of that. If you just give me the value 1, that's not correct. It should be an equation, x equals 1. Okay, now as a reminder, how do we know if this parabola is pointing up or down? We're going to use our a value. Our a was 1. Because a is positive, a is 1, it's going to point upward. Remember from earlier in this course and in your college algebra course, if your a is 1, that means your stretch on your parabola is that it's going to be pulled up 1 from the vertex. So I'm going to pull it up 1 on either side on the vertex. And remember that axis of symmetry means we should have the same picture on both sides like we just had. So the stretch upward was 1, so I pulled it up 1 from the vertex on either side, and there's my perfect parabola. And I'm almost done. I've got my vertex, I've got my axis of symmetry, and I need to find out when am I increasing and when am I decreasing. Well, I'm increasing or going up from left to right on my right-hand side of my parabola, which starts at 1 and continues all the way towards infinity. So I'm increasing from 1 to infinity. Remember, when you're increasing or decreasing, we always use parentheses, never brackets. We always use open intervals. And when are we decreasing? Well, we're decreasing on the other side of the parabola, which is up to 1. So that means on the left-hand side, which means starting at negative infinity and working up to 1. And again, we're always going to use parentheses when we're doing increasing or decreasing, no matter what. Notice infinity also always has a parentheses no matter what. That's just a rule. So what we've done is we've used this formula x equals negative b over 2a, and it helped us find the x coordinate of our vertex. Once we had the x, we could plug it back in, and that would get us back a y value for our vertex. That x equals negative b over 2a also gave us our axis of symmetry. It actually gave us the full equation, x equals 1. And it also gives us that same value, also tells us when we're changing from increasing to decreasing. So that x equals negative b over 2a gave us 4 parts of this. It gave us the first value, our x value for our vertex, our axis of symmetry, and where I'm changing from increasing to decreasing. So what this tells you is you should be using this x equals negative b over 2a a lot and seeing the number a lot because it's a key part of your parabola. Let's take a look at another.